topic number 1, a little mean value theorem. We grab one other concept that, interestingly, is in this chapter, but what it really is a preview of the next chapter. And I've kind of been talking about it, but what we do now is officially preview it. Just so you know, I'm not just like kind of doing this as filler. It actually is in chapter 4, and I like that the author does that because it starts getting us to think about, well, doing problems backwards. Now, you think maybe there'd be a better name, and in fact there is another name, but for now, because this is one of the names, we call it an antiderivative. Again, we do have a more creative name, but an antiderivative is really the backwards version of a derivative, or as you're going to discover, trying to find the original function. So the way I usually present this is a little bit of, what do you think? Like, I'm going to give you a derivative. You're going to try to figure out where it came from. You're going to try to figure out the antiderivative. And how will you do that? Let's say I tell you that the derivative of some function is 4x cubed. So f prime is 4x cubed. Where did that come from? What would be f of x? Now, I'll share, and I'm going to call on you here, but especially the very first time that we do one of these, it helps if you're already trying to reverse, if you're trying to think, okay, wait, where would the 4 come from? Wait, it's x cubed, so, and if you're trying to think backwards, that's exactly what I'm trying to get you to do. So what do you think? It's x to the 4th. If you think about it, that 4 was destined to come down, and it was also destined to be subtracted. And of course, that's going to give us 4x cubed. X to the 4th is called the antiderivative. It's also the original function. How about if the derivative is x squared plus x? Then, well, where did that come from? The derivative is x squared plus x, so the original function I got a little trickier on you here, didn't I? Let's talk exponents. I was very impressed months ago. Many of you were catching on to this, that you realize there's certainly a connection between the exponents. So this next exponent, or I'll say the original exponent, would have to have been to what power? Right, to the 3rd. So it has to be 1 higher. Likewise, it would have to be 1 higher. What number would have to be waiting here for this exponent if it needs to end up equaling 1? So what number would have to be waiting there? And are you ready to say 1/2? Okay, now this is a little bit of the thinking, like kind of just thinking backwards. And it's funny, if this was the first thing we did back in September, you would think that this was forward thinking, but we're just kind of thinking backwards. Is there anything else that you want to sort of add here to the cause? Like literally add to the cause.
Is it possible that something could have been dropped because of just like a constant?
Very good. It's actually 100% possible, and therefore, officially, we have to note that. We say that the antiderivative could be, well, 1/3 x cubed plus 1/2 x squared plus any number, any constant. Likewise up here. I like how you said that it would be dropped because we know the derivative of c would drop to be 0, but it needs to be noted. Now, what I just showed you here, or what I was trying to help you guys to figure out, is actually what we call the reverse power rule. The reverse power rule, again, you think maybe we have a better name for it, but it's just the power rule in reverse, where you take your exponent and now you add to it. You're so used to subtracting, but now you add to the exponent. And then I'll tell you, this coefficient actually represents dividing by the new exponent. Dividing by the new exponent. Here I have the reverse power rule. Just got to help it along here. The reverse power rule says that I can get my antiderivative by adding to the exponent and then dividing by that new exponent. And the nice thing about this, I don't want to say you don't have to think anymore, but you actually don't have to think so hard. You really can just follow this rule. Again, with the exponent. The derivative is 2x to the third. The derivative is 2x to the third. The antiderivative, in other words, the original function, well, it's just going to be the reverse power rule. Okay, and yeah, you're probably going to do it in your head, but if I add to that exponent, if I divide by the new exponent, okay, you can trust it. It's going to be right. So, I mean, even here with this extra 2, of course, 2 over 4 actually turns into 1/2 x to the 4th. Don't forget your plus c. The derivative is 4. The derivative is 4. So the antiderivative, in other words, the function that it came from,
Since it's constant, it could be the first power to the fourth.
good. Yeah, now sometimes this makes people pause. It's like, should it be x or well, listen, yeah, since, like Bryce said, since it's a constant, it had to have come from 4x. But technically, it fits this rule because technically, we had x to the 0. Now, most kids aren't going to write that, but again, technically, it's 4x to the 0. And if I add 1 and divide by 1, it's probably a little extra thinking that's not needed, but just to say it works. It comes out to be 4x plus c. One more, and then we'll move it along to some other backwards thinking. Because, yeah, anytime you have a function to a power, all you got to do is reverse power rule. All you have to do is add 1 and divide by the new exponent. So it's really sharp and snazzy when you have an exponent that's a fraction or a rational exponent. Now, trust it, if you add 1 to a third, you get 4/3. Okay, if you add 1 to a third, you get 4/3. But we're going to want you to quickly or eventually clean that up. Like, I don't want to see you divide by 4/3. I want to see you multiply by the reciprocal. I want to see you multiply by the reciprocal. Plus, it makes it really clear that the answer is right. Because if you check your answer, if you bring the exponent back down, like we did the first half of the year, then we get a nice little cancellation. Okay, so let's make sure we clean it up and write it as a coefficient 3/4 x of 4/3. Now, it's interesting. We're going to spend the second half of the year talking about antiderivatives. So there's no way that we can talk about all of them in 30 minutes. But I am trying to just get you to start thinking. Also, don't want you to get too panicky. Like, is he going to just pull out some random? No. Okay. The ones that we're doing here are more or less some of the more basic. And a few of them are to help you think about rules. Okay, this one is a rule. You kind of have to say to yourself, where have I seen 1 over x before? 1 over x. What function always creates a 1 over x? And so that would have to be the antiderivative. I don't always know when you're silent. Maybe you're not sure if you're going to answer. Maybe you're just not sure. But again, it's a rule. It's the ln. ln, remember, the derivative of an ln is 1 over. So some of them are like that, where it's like, okay, we're going to have to think of a rule. Like I said, don't worry. I'm not going to suddenly go find the most detailed rule, but I am kind of going over some of the more main ones, and you'll see these in your assignment. And you might see like a little variation. So, sure, the trig functions. It was like one of the first rules that we had. And you stood over at my desk and you said, the derivative of sine is cosine. Oh, does that mean the antiderivative of sine is cosine? Okay, not quite. It means, where did sine come from? It means, what did you take the derivative of? What did you take the derivative of to get sine?
Negative.
Good. How are we doing with the negative? How are we doing with the negative? You should be saying to yourself that the derivative of cosine is negative sine. So I kind of need to get that negative into my antiderivative so I get positive sine. I forgot the plus c. Shame on me. Because we have a funny joke that we'll tell when you're ready to laugh at something like that, and it has to do with plus c. So we don't want to forget that. My bad. Here, I'm looking at my notes. There's no reason to skip this. It's only going to take a minute to write it down anyway. But it'll kind of get you thinking about one more trig function. Or really thinking about one more rule with trig functions. So the derivative equals secant squared. Listen, sometimes even for myself, I'll say to myself, the derivative of what is secant squared? Honestly, that's the kind of thinking you're doing. The derivative of what is secant squared? The derivative of tangent, right? The derivative of tangent. So tangent plus c is the antiderivative. Okay. Now, one more thing with antiderivatives, and it actually has to do with finding c. It has to do with finding c And it basically, I got to show you kind of the language. So when you're presented with a problem like this, it'll say to find the exact antiderivative. So when you're presented with that, and you have some extra information here, what it really is asking you to do is find C. The other thing I want you to realize is that you would need some extra information. Basically, you would need a point if you were asked to do this. All right, actually give you a little exit problem on this. I know we've been kind of pretty heavy here on a Friday, but a little exit problem. Maybe it's something you'll do as a quick homework, or maybe you'll be able to do as an exit problem, but let's go through this. I think you're going to say sooner than later that, oh, that's what I would have done anyway. It's almost like calculus common sense, but let's make sure that it's what you would have done anyway. Now, I figured I'd mix in how to deal with this fraction. So we're kind of taking care of another little issue here. How do you do the antiderivative of a fraction? Remember how often in the first half of the year I was making you think of exponents or negative exponents? Okay, it's another, that's why I was doing that. Okay, to be able to think about this problem, you need to think negative exponents. Now see what I did with the 1/4? I literally pulled it out as a 1/4. Okay, but now I can add to this exponent. Okay, please think of it as a negative exponent so that before you do the reverse power rule. So I add to the exponent. Negative 3/4 plus 1. Oh, 1/4. Okay, so I divide by, oh, that's nice. Those are going to cancel. Okay, we can be nice to you here. So the original function, the antiderivative, is x to the positive 1/4 plus c. Now, technically, that's called a general antiderivative, just because it could be generally any constant. If I want to find the exact antiderivative, then I need to find the exact c value, the exact y-intercept. You see, kids, it's really just plugging into this equation x and y and solving for the y-intercept. Okay. Kind of like you would have done anyway, or done it probably like in an algebra class. Be careful. Sometimes people confuse this C with the mean value theorem C. Do I understand? It's two types of C's. This is just the y-intercept. It's part of the final answer. The C that we did at the first half of the lesson was honestly a whole different idea. It was more of a point that was in between A and B. So anyway, just be careful that you're keeping these two C's different. I want to get you to do one of these, and you might do it in a little bit of time that we have.